In this tutorial we are going to show question number 7. This is kinematics chapter and it's a board exam question. I took this question from kmziaulh book, question number 7, and its exercise is 16.3. Question number 7 we are going to try right now. I'm going to use the different color. So read the first question. It's given here velocity v meter per second, and this is velocity expression with exponential e to the power 2t minus 6 e to the minus twice t minus 1. It is written there. Find the expression for the displacement. The first question is asking the displacement from velocity. If we want to move the displacement, we have to integrate, and you may know the integration of the exponential. If you don't know how to integrate and differentiation of the exponential, you may see my previous differentiation. So first question, we need to integration. So x, this is the expression for displacement. Let you integrate e to the power 12t minus 6 e to the power minus 2t minus 1, then dt we can write. So if we integrate, it gives us coefficient of t is 2 written, so we needed to write 1 by 2 because this is the rule of the integration, twice t. Then again coefficient of t is written minus 2, so we can write here minus 6 divided by minus 2 e to the power minus 2, and 1 is a constant, I mean one numerical value, then we have to write c, and this is the plus c is the constant, integration constant we have to write. So next one we can write 0.5 e to the power 2t, I'm simplifying that part, plus 3 e to the power 2t minus t plus c. Now we have to find out the value of c from here. It is written here t seconds after passing fixed point O. T seconds after passing fixed point O. It means that when t equals to 0, its displacement is 0 as well. So let me put this value in our equation to get the value of c from here. So we can write here when t equals to 0, x is 0 as well. Let me put this. So we can write from the equation 0 equals to 0.5 e to the power 0, we know it gives us 1, then plus another value 3, or it is e to the power minus 2t, extremely sorry, 3 e to the power 0 again minus 0 plus c. So from there we can say c equals to minus 3.5, because e to the power 0, since e to the power 0 we know that it is 1. So we got the value c. Now we can write our final expression, which is x equals to 0.5 e to the power 2t plus 3 e to the power minus 2t minus t, then another part minus 3.5. So this is our final expression for the displacement. Now we are going to move to the second part of this question. We have done the second part of this question written here. Use the substitution u equals to e to the power 2t, or otherwise find the time when the particle is at rest. If it is written there in my previous tutorial, I also told that if it is written there rest, it means that velocity we need to consider 0. So we have the velocity expression. Let you write the velocity expression. It is e to the power 2t minus 6 e to the power minus 2t, then minus 1. We need to consider 0. Now let we use the book expression e to the power 2t. Let we replace e to the power 2t as a u, then we can write it u minus 6 by u. You know why 6 by u? Because 6 e to the power minus 2t, we can write it 6 by e to the power 2t. That's why if we replace, we can write it 6 by u, then minus 1 equals to 0. Now simplify and find out the value of u. If we multiply on the both side by u, then equation becomes u square minus 6 minus u equals to 0. Now make the middle term break. U square minus u minus 6 we can write equals to 0. So we can write here u square minus 3u plus 2u minus 6 equals to 0. So take u common, u minus 3, then plus take 2 common, u minus 3 equals to 0. So two values of u are there, one is 3, another one is minus 2, but we would not consider minus 2 as a value of this expression, because we know the exponential curve is above the x-axis, means the all values are positive, there is no negative value, it's supported. So we should consider, therefore we can write e to the power 2t equals to 3. So let's find out the t value from here. T we got from here. Oh, we need to apply the opposite of the exponential, then it becomes 2t equals to ln 3. If we apply the logarithm on the both side exponential, then t equals to half ln 3. Half ln 3. This is our answer of this question. Hope you understood the way we did the question. Next part is last part of this question, which is question number 3. It is written here, find the acceleration or at this time. At this time means the when the velocity t equals to half ln 3, at that time what is the acceleration. So we have the acceleration expression? No, we have to find out the acceleration expression first. So we can differentiate to get the acceleration expression. I'm doing right now part 3, a very important question as well for the board exam question, exponential question, always important. So let me differentiate that part. D by dx of, sorry, d by dt of the expression is written e to the power 2t minus 6 e to the power minus 2t, then minus 1 it is written. So if I differentiate this one, and now coefficient of t comes as a multiplication in front of the exponential, so it would be 2 e to the power 2t, first expression, then another one 6 to the 12 plus 12 e to the power minus 2t. Now we have to put the value, exponential value, as a 3. So let me use this value in our acceleration, e to the power 2t equals to 3. Then it is 2 into 3, because I am replacing this e to the power 2t directly as a 3, and another value plus 12 by, because it is with a negative power, we can write it below e to the power twice t, then it becomes 6 plus again 12 by the value we got from here 3. So hope you understood. 6 plus 4, which gives us 10, and its unit is meter per second square. In exponential case, this is the best practice if you could use the whole thing e to the power 2t as a t, rather than writing t equals to half ln 3. If you use the t equals to half ln 3, you would get the same answer. So this is the best way to do this question. So its answer is 10 meter per second. Hope guys, the way I did the question you understood. The one question is remaining. Next tutorial definitely you would get it. Thanks for your time for watching my tutorial.